Welcome back to Think Design Work Smart. I'm Alex Bolboaca and I'm coming at you from the Mozaic Works studios. And what I have for you today is quite a shorter video about 3 Gen AI practical use cases. These are some use cases that I've seen people from software development using. And I think these are beyond the ones that you would expect. These are some that are interesting, and we'll discuss a little bit more their implications and what they can lead to. So first of all, when we talk about Gen AI, I'm talking about the LLMs, large language models that are fit for software development. And of course, the big use case here is generating code. And we did a whole video on code generation that was published a few weeks ago, and about the limits and the issues with code generation using all the technologies, including LLMs. But today we'll dive a little bit deeper into some things that I found really interesting. I've been monitoring social media and various sites about usage of Gen AI in practice. So beyond the marketing hype, beyond what the companies are saying that, you can produce a ton of code and so on. That's not very interesting. What I'm mostly interested in is in what are the actual changes in lives of software developers. And here when I'm discussing software developers, I'm talking programmers, testers, technical leads, architects, everybody who is involved in software development. Okay, so 3 cases, and I'm just gonna go through these quite quickly because I'm mostly curious about your reactions to that. First of all, the ones that I found very interesting, bringing former technical people back to development. This is a common situation in software development. You have people who have been programmers, who've been senior programmers. They've been really good programmers, and at some point they get promoted to software architect or technical lead or some kind of technical manager, and they don't have time to program anymore. And because of that, they get out of touch with the field. All right, they don't have the energy and knowledge and the time to go back and try to understand the latest things in programming languages and all of that. Okay, they still know a lot of technical stuff, and their minds are built and optimized for that because they had a lot of experience, a lot of training. And when you are in the position of an architect or a technical manager, you still need to think in technical terms, only you need to think at a higher level. So, and from a different perspective. So because of that, it's, from my point of view as a coach, it's a pity that the potential of these people is not really used up to its fullest in an organization. And what I mean by the fullest, it would be great if from time to time, for more complicated things, architects, technical leads, technical managers would be able to provide kind of a guidance and say, this is kind of what I want. Now, of course, this is not production ready, but this is kind of what I want, and for you to get it from here and take it to production ready. Of course, maybe you'll need to rewrite, maybe whatever you need to do. You don't have to keep this code, but this is kind of what it's supposed to do, right? And this is something that AI and LLMs can actually bring back. So I've seen reports of people, architects, technical managers, who took one important requirement that was important for the business or for the architecture and used LLMs in order to generate code that fitted their use case in order to explain it better to the teams. And I think that's just great. It's we keep telling architects, for example, that architects should provide sample code for various patterns that they want to include in the architecture for reasons of mostly non-functional requirements. But it's in many situations, architects haven't written code in 5 years or 7 years, something like that. The language has diverged. They don't know anymore how to write that code and what libraries to use and so on. And I believe this is a great way to bring people back into development and kind of bridge this gap between people with a technical experience but who are not involved in the day-to-day programming anymore, and bring them back closer to the teams and bridge this gap. This is a great development. I think it can lead to many improvements in organizations once you start embracing this. I think it's really cool. The second one that I found was translating between different languages. And that's, again, it's a perfect use case for LLMs because LLMs are particularly focused on languages. So translating between English and Chinese, for example, is kind of at the same level of difficulty as translating from Python to C, if I were to give you an example. And in this particular case, the report that I've seen was a programmer who wrote the code in Python and wrote a lot of tests to cover the whole Python code, and then asked an LLM to translate the Python code into C, and after that ran all the tests, still written in Python, on the C code, and made sure that they are all passing. And with this move, the memory and resource usage and so on was optimized. I don't know, I think it was something like 4 times or something like that. And this is something that makes a lot of sense. I could definitely see this step where you take advantage of a higher level language where you can write code faster, easier. But then instead of using that code as the end product, you transform it, you translate it into another programming language, and you end up that is more performant, let's say Rust or C or I don't know, C++. And by doing this, you make sure that you consume less resources, that your program works faster, and so on. Now, this is not the end all of optimization, all right? It's not something that you can still have very unoptimized code doing that, because it matters a lot how you use, for example, files or how you use memory and so on. But it's still, if programs can go even twice faster. And if they can use less resources, why not? I mean, it's a kind of a free win. And in my case, since I'm writing tests anyway, it would be very easy to just translate this and test the result and see what's going on. Now, of course, one challenge here is that it will be, you cannot use the C code as something that you change, more or less, because it's basically the result of a translation. So if you want to keep your source code, you manage the source code in Python, and then translating to C and compiling the C code and testing it is one of the steps in your build process. But the changes that you make will be in the Python code. So it's an approach that has limitations. It's not an end-all approach that solves everything, but particularly with the need for using less resources, for doing more carbon efficient code, I think it will start to make sense. And I think it's a use case that it's quite interesting, honestly. It's very interesting. Okay. The final one is prototyping. And here you can prototype a bunch of things. You can prototype REST interface, a REST API. You can prototype web pages. You can prototype UI, UX. So there are prototypes of various levels where using LLMs and generative AI really makes sense. Because with prototypes, what we want is a very quick result, something that we can get up running, showing, and something that we can show to people. In this case, a simple thing would be to generate prototypes and then to use them with various potential users in order to get some feedback on the prototype. Or you can show whether something is possible or not, so do a kind of feasibility test, things like that. It's not for prototypes that would be deployed in a production-like environment with all the security, with very few bugs and all that. But it can be for prototypes that are deployed to a very limited number of users, like a closed test with friendly users, something like that. So I can definitely see this as a use case. And I think it makes sense. Once again, prototyping is something that we don't do enough of. And if we have these tools that help us do faster prototypes, why not take advantage of those? Now, once we discuss these three use cases that are actually happening today in various environments that programmers are actually using, and not only programmers, as we've seen, or former programmers, it's interesting to see a few things. So first of all, we can see that AI, as it is now, it's not replacing programmers, but it's rather expanding or enhancing the possibilities of various technical people. Right? And it's something that I've learned about every tool. So every tool is actually helps you enhance your performance. It helps you get things done faster, or it helps you do things that you couldn't do before. Oh, and this reminds me actually of a fourth one, which was a company that has customers and they would be asking for, they have a specific budget. What can you do for us within this budget? And suddenly with Gen AI, they were able to do more with the budget than before, because some of the work that would have been very intensive before is now amplified by AI, and it gets done faster within a smaller budget. That's another interesting use case. So, but what we see is basically an amplification of existing potential. And this is what's happening with AI until now. And this brings me to the next observation, which is there doesn't seem to be a killer case for AI right now in software development. It's not that we have some AI that can generate the whole applications and they just work and so on. No, it's people need to be involved. Sure, there are some attempts there, but they don't seem to be working. They seem to be mostly marketing, mostly hype. And sure, some people who are not programmers are able to use Gen AI in order to create some simple things. Yes, but when you do this without knowing what you're doing, you are likely missing a lot of potential issues that will hit you eventually. But it doesn't really matter if you're not a professional programmer and if millions of users or thousands or of users depend on you. It doesn't really matter. I mean, if you just do this for yourself or you build small games that you sell, perfectly fine. No problem with that. The problem lies in, when we are really in a professional environment and we want things to be as reliable, as secure, and as fast and so on as possible. So to me, based on what I'm seeing now, there isn't really a killer use case for Gen AI in software development. Now, it's still possible that this will come. I don't know, but it's been some time now and we haven't seen it yet. And so this leads to the question that is on everybody's mind, it seems, lately about Gen AI, which is this a business that is sustainable? And in reality, honestly, we don't know. Right now, these businesses are funded by big organizations, by Microsoft, by Google, by Amazon. And so it's still very unclear whether they can actually make their own business sustainable. The expenses for Gen AI are incredibly high, it seems. So, and the cost of training and the cost of research and all that. So at this point, the reality is we don't really know whether there will be a business there. And it's possible that some of these services will kind of scale down or become more specialized, but we'll have to see. This is just speculation at this point. However, it's very interesting that we see these use cases coming up. These are emergent use cases based on using AI in new ways. So AI enabling new things or enabling you to do things faster that you couldn't do before. as fast. So these are some of the things I found. Now, I'd be curious, and please let us know in the comments, how do you use GenAI? Have you used GenAI? How do you use it? Is there any of these use cases that sounds interesting to you? Are there any other use cases that you have tried? Let us know in the comments. Thank you kindly for the view, and until next time, remember to think, design, and work smart.